Hey, this is Alejandro, and I'm going to show you guys my code that I made for the app designer. So this is how our app looks. There is an axis to show the real-time temperature over time. And there's also these edit fields, which show the value of Fahrenheit and Celsius. And then this lamp right here that tells you when it's running. And then there's the on and off buttons and the save run data. So if you look into the code, when you start it up, this is what runs. And most of this code is made by Yisin. We actually made the code separately and then integrated it with the app. So when we made the app, we added this. So once the app starts, stop equals true, so that the app isn't running, and the lamp is white. So when we look over here, when you press the on button, this is what's going on. And then these are all the global variables. We could have made them properties, but it was working with global, so we thought why change it. So when you press the on button, stop is set to false. And then, even though stop is set to true here, this will override it. So stop equals false, and then it's going to cause this if loop to run. And so I'm going to need the start time, which is right now, seconds, which are 10 seconds intervals, and then H, which is the animated line. And this is what's going to be plotting on the actual graph. And so then this is some of the video files. And then this is what we're going to need in terms of the app. So stop equals false. It's going to turn the lamp green. And then this is how we're going to get our Celsius temperature and our Fahrenheit temperature. And as you can see, this is just the conversion formula to turn Celsius into Fahrenheit. So right here, these are the edit fields that's going to cause the values of temperature C and temperature F to show up right here and updating real time. So these are related to the block. And we had these in different formats before we actually made the app, because we made it before to create another image, but we had to modify it to where this is like the limit for the x-axis and this is the limit for the y-axis. So as you can see, it'll show t minus seconds, which is 10 seconds. So it'll show 10 seconds before and the time. And then right here, this is the interval of the y-axis, which will show about 50 degrees Fahrenheit less than and 50 degrees over the current. Okay. And so in this right here, add points. This is going to be the animated line. This is going to be the x-axis. This is going to be the y-axis. And then drawn out causes it to drop. So if you look further, if stop equals true, then it'll break from this loop. Okay. And when you press the off button, stop will be set to true. The lamp will stop and it'll turn white. And we made it so that if it stops, it'll delete the animated line once on is pushed after the off. And so right here, we have the data for saving the run data. And Yisin was actually responsible for making this. So he made it so that when you press the button, it'll save the run data.
Hi, here is Yan, and that's what I did. So for our project, I mostly did I did most of the electronic parts. So, and we didn't use the Arduino Uno board. We go for STM32 board because so we actually can't use the MATLAB to drive the board. So actually, I use the Arduino IDE to do the coding for our project, and in our project, we use the DHT11, the temperature and humidity sensor, to collect data, and an OLED screen to just do some extra work to make it look better. And so that's our setup. So the serial booking and update rate is pretty fast, just because because I want to send some, I want to play video on our screen, so that's why it's so fast. and that's the menu is fairly simple. So there's only two lines. The first one is read the data come from the server port, which is mostly the data for our video, and so that's the sentence that draw the bitmap. So show the friends on our screen, and so there's the idea of customize function down there. So this one actually just collect the data and print it out, print it on our screen, and also write to the MATLAB through the serial port. So, and I also include the library actually just make our OLED display running, and that's mostly the Arduino part. And so for the MATLAB part, so I actually need to our board to communicate with our laptop. So in the startup, I set so I actually just goes random sentence to find a serial port. So right now I set it to COM5, which is the COM port I usually use on my laptop. And right now it's so that's basically the setup for the COM port. So MATLAB will know which port it should get it from and send it through. So right here, we open the COM port just before all of those loops and everything else. Just do the preparation, and so that's actually the RAM for the show storage for our outputting data, which is 2048. So that storage that actually is enough space for 2 frames, just in case so just make sure those data won't get stuck on before they get sent out. And so in our main loop, our main project, so actually right here, so before those are the video parts. So after they send the data to the board, and so in Arduino parts actually, so when it get the data from the MATLAB, it actually just send the data back to the MATLAB. So right here, so you can see, so right here, so that's read temperature, and make the temperature, so OLED print the temperature, and serial print the temperature. So right here. So okay, so after sending the video data, we'll get feedback from our developer board. So I actually in here actually set a stop button right there, but we never use it. But just it's for the testing. And so you get the response, which equal to the temperature data, the temperature figure, and here we'll calculate the temperature.
Hi, I'm Chen Zhixie, and this is what I did for our final project.
The first and second line is to find the address of the picture. Then the first for loop, read each image and change it into double precision. The third for loop, inside the second for loop, save X pixel into 1 byte, then store into array B. The second for loop will circle the third for loop for 1024 times, which is 1 kilobyte. After that, create an empty bin file inside the first for loop. Because it is inside the first for loop, each bin will be named separately. Then open the file, save the array B inside the file, and close it. So this part is to play the video on the board. The first line is to find each bin's address. Then open it, write it out, and close it. This COM1 is the global variable, which already defined in the start function, and it go to the serial port COM5.
Okay, so this is our app, and as you can see, when we click on, it'll start to plot the temperature, and it changes the curve according to the changes in temperature. And in addition, these edit fields also change along with the temperature. And that lamp is green right now because the app is running. So also when it's running, this is the screen that we have attached to our microprocessor. And as you can see on the left, that's the temperature in Celsius, and on the right, that's the temperature in Fahrenheit. So when we click off, the lamp turns to white, the graph stops, the screen stops, and then if we want to save the data, we click the Save Run Data, and over here, we see that it saves as 1.bmp, and you can open it up and see the changes in temperature.